Hi guys, welcome back to another episode of Learn Smart with Faith Olaseyinde, and today we are going to be treating questions just like I promised in the previous video on differentiation. Yeah, the idea is just for us to have an understanding of how to solve this question, because you are going to need this idea so much in many other series of videos to come. Yeah, you will need it, so that's why I'm taking a little time to break this down for you. So in the previous video, we treated some of the rules. Today we want to see how to, answer some of the questions based on those rules. So the first question here is y equals to exponential x. Yeah, this is actually one of the rules we treated in the previous video. And by the way, if you've not seen the previous video, please go and check it out because you really need it. And if you know these rules already, let's continue. Let's fire on. Yeah. Differentiation of exponential x is still exponential x, doesn't change. Now the next question is differentiation of sine x. Differentiation of sine x is cos x. It's just one of the trig function rules that you have to know. Now differentiation of ln x gives us 1 over x. Yeah, that's a log function rule. Now let's try something a little more, complex. Yeah, just a little more complex. Now we can see this question, y equals to cos x sin x, and we are told to differentiate this. You can see that this is a function, this is another function. We have two functions multiplying themselves. Now if two functions are multiplying themselves, then you have to use the product rule. What is the formula for product rule? The formula for product rule, dy dx equals v du dx plus u dv dx. So it means one of them here has to be tagged u, the other has to be tagged v. It doesn't really matter which. Anyone can be u, anyone can be v. So now let's solve this. Dy dx. V, write v first. V here is sine x. Now du dx, we're differentiating u. In this case, that's what it means. So differentiating u here is cos x. Differentiating cos x gives us minus sine x. Now plus u. Let's write u. U in this case, we're writing u. Now differentiate v. V in this case is what? Sine x. The measure of sine is what? Cos x. So multiply, you get minus sine squared x, then multiply, you get cos squared x. So the answer here is cos squared x minus sine squared x. As simple as that. Yeah. So that was the product rule. So let's try something a little more different. Now you can see this question. There is a function inside another function, right? 4x plus 1 is a function which is the one inside this function, this outer function. Everything is raised to the power of 3, right? So if you have a function inside another function, that means you're using the chain rule. Now how do you solve the chain rule? Like I said, we have the long form and the short form, but I'm going to be sticking to the short form. Now, the short form, we are going to differentiate the outer function as if the inner function was not there. So let's assume this 4x plus 1 wasn't there. Let's assume it was just one random letter, like y equals to a raised to power 3, and you're told to differentiate it with respect to a here. What you would have gotten is 3a squared, right? 3 comes down to multiply, then subtract 1 from 3, right? Yeah. So let's just do it assuming 4x plus 1 wasn't there. So that will be equals to 4x plus 1, 3 comes down to multiply, then this one becomes 2, right? Now, but because this 4x plus 1 is a function of its own, you have to differentiate it too. So differentiating 4x plus 1, you get 4. Then what you just have to do is multiply it. At the end of the day, you have 12 4x plus 1 all squared. That's the answer. So let's go ahead to try y equals to exponential 3x. Now we can see that y equals to exponential 3x is another question. It is somehow looking like the one we treated earlier, which is y equals to exponential x, right? Yeah, but the only thing is that it has 3 here in this case. So we can see it clearly now that 3x has now made it another function at that top there, right? So there's a function, the original function itself is exponential x, right? But the x there now carries a 3, so that means there's a function inside of it now. So that means we are still using what? The chain rule. There's a function in another function. Now the idea of chain rule is that original function itself, differentiate it assuming that inner function was not there. The original function is exponential x, right? And differentiating an exponential function remains the same exponential function, right? Equals to exponential 3x. But because that 3x is also a function of its own, then you have to differentiate it as well. So differentiating 3x here gives us what? 3. Then times 3. Then 3 exponential 3x. Now y equals to sine 3x. Now we can see sine x is also a function, like is a standard function of its own, right? But there's a 3 inside of the x, so there's a function inside of it now. So still chain rule, differentiate the original one like the one inside was not there. So the variation of sine here will give us what? Cos x. Cos x. Now, because there's an inner function, differentiate the inner function itself, and the variation of 3x will give us 3 then times 3 cos 3x. Yeah, we are advancing. Now let's go to the next one. Y equals to 4x squared sine 3x. Now this is a product rule question, right? This is a function of its own, this is another function of its own, and they are multiplying themselves, isn't it? Yeah. So we're going to solve it using product rule if we are differentiating this, and this is still the same product rule. dy dx equals to v du dx plus u dv dx, right? Still remember that. Good. So one is tagged u, the other is tagged v. It does not really matter which is tagged u or which is tagged v. Now dy dx, now write v first, sine 3x. Now du dx, the next one is du dx. That means we're differentiating u, this u with respect to x, and differentiating it gives us what? 8x, right? The 2 comes down to multiply. The 2 comes down to multiply. Then subtract 1 from 2, right? So 2 times 4, 8x, then 1, which is 8x, isn't it? Good. Now plus, write u in this time around, then differentiate v. This time around we are differentiating v. But if you look at v very well, v is what? Sine 3x. Usually it's supposed to be sine x, right? Because there's a 3 inside, that means there's a function inside another function. That means this one in itself, you have to solve it using the chain rule. Yeah, you have to solve it using the chain rule. So that's solving this one will mean cos 3x, differentiating it exactly right, but because there's another function inside of it which is 3x, differentiate that one too. That's times 3 cos 3x. So that means this place is multiplied by 3 cos 3x. So in case you just want to simplify it, then we just have to multiply everything necessary, then you have this. That's the answer. That's the answer. Now y equals to sine x cos x. That was the last question for today. Yeah, now this one, they are dividing themselves, so that's what the quotient rule. Now the upper one must be u, the lower one must be v. It's a must. And the formula for quotient rule equals to v du dx minus u dv dx divided by v square. So now let's use the formula. V here is cos x, du dx, that means we are differentiating u in this case, and differentiation of sine here is what? Cos x. Now minus, now we're writing u here is sine x. Now dv, we are differentiating v is cos x. Division of cos x equals to minus sine x. Now all over v square, v is cos, so cos square x. Now simplifying this, we have cos squared x minus sine squared x over cos squared x. Then we have cos squared x plus sine squared x over cos squared x. If you remember from your trig function from last semester, cos squared x plus sine squared x is 1 over cos squared x. And if you remember from trig function, 1 divided by cos is sec, right? Inverse of cos is sec. So sec squared x. So that's the answer. The starting from this place below, like that, it's just trig functions. It's nothing so difficult. Your understanding of trig function will pave the way there. But the idea is that you know how to use the rules, you know how to use the product rule, the quotient rule, you know those rules on how to use them. And at this point, I'm going to round up this video. If there's any question you do not understand, send them to me and I'm going to take time to trash them out. In the next video, we're going to be treating implicit functions. Thank you very much. I remain Until we see again in the next video. Peace.